Hey everybody, hope you're doing well. This is the final video here for week 7 of the 4th marking period. This will go through section 4 of unit 6, which will review how to interpret circle graphs. So a circle graph simply compares individual results to the overall total. Typically we use these if we want to represent things in terms of percentages, comparing certain categories of things out of 100%. So we're going to go through 3 examples here. Some basic interpreting questions here, and then that will should be enough of a review here to make sure you can adequately interpret these. So let's go ahead and talk them through. Company sells 720 pairs of sneakers in a month. Results of the sales are included in the circle graph. So you can see everything displayed there. You've got 5 different wedges, all with the percentages included. So first question here, in A, which type of sneaker was sold the most? Well, obviously, if I want to know which one occurred the most, I want the highest percentage. So if I look at my 5 pieces, Nike has the highest percentage, so I would say Nike sold the most. Question B wants to know how many Reebok sneakers were sold. So I see Reebok is 15% of the sales, but it's not asking what's the percentage. It wants to know how many sneakers were sold. To figure that out, I want to take 15% of how many total sneakers were sold, 720. So again, mathematically, I do 0.15 times 720, and the amount of sneakers that would be sold that were Reeboks would be 108. Part C, approximately how many more Nike sneakers were sold than Adidas? There's technically 2 ways you can figure this out. Here's what I would recommend. So it's saying how many more Nike than Adidas. That basically means I need to do a subtraction problem somehow, some way. Here's the easiest way to do it. We know Nike sold 32%, Adidas sold 25%. So what I would want to find first is the percentage difference in the sales. So Nike was 32%, Adidas was 25%. The difference in sales by Nike, they sold 7% more in terms of their sneakers. That's a crude way to figure it out, but that's a start. So again, if it was asking for what's the difference in percentage, that's all you would do. But since it's asking how many more Nikes were sold, we want to use that 7% and apply it to the overall amount of sneakers sold, which is 720. So what I'm going to do from here is I want to find 7% of 720. Now, when you punch this in your calculator, this is always a point where some people just screw it up by accident. 7% is 0.07, not 0.7. 0.7 would be 70%, and that's very wrong. So this would spit out an answer of 50.4. Now, theoretically, you can't sell 50.4 sneakers, so we would say, again, doing some smart rounding here, we would say about 50 sneakers. So again, some basic math there, but if you're asked to do a basic comparison, how many more, do a little bit of subtraction, and then if you need to go beyond the percentage and actually find the amount of items, which in most cases you will, do exactly what we did in part B, take the percentage out of the total amount of whatever item you are dealing with. All right, so we got another circle graph here. In the second example, there's 880 students who attended Cove Elementary School. They were asked about their favorite sport. Part A lists 2 sports that represent half of the students in the school. Well, if I want half of the students represented, I want 50%. So 2 sports that make up 50%, there are 2 combinations you could choose. Soccer and baseball, because soccer is 30% and baseball is 20% combined. That would make 50. The other combination would be soccer and basketball. Same thing. Soccer is 30, basketball is 20, and that combined makes 50%. So again, it says list 2 sports that combine it. So there are other combinations you can make to get to 50%, but that would require 3 sports. So again, just making sure that you answer the question that's given and not giving more information than you need. Part B, what percent of students did not choose track or gymnastics as their favorite sport? So the key word is not. So we want to know who did not choose track or gymnastics. So that means I want to choose everything that's obviously not those things. So what I can do here is look at and say, all right, well, soccer is not out of those sports. That's 30%. Same with the baseball. That's 20%. And basketball. In total, 70% of students did not choose track or gymnastics because they chose the other 3 sports that were listed. Part C, how many more students prefer soccer than basketball? So this is pretty similar to the Part C question on the last example. So again, how many more? We're going to subtract. So soccer over basketball, that means 30% for soccer, 20% for basketball. I want to find the percentage difference first. In this case, it'd be 10%. And then again, if I want to find how many more students, once I figure out the difference in percentage, apply it to the overall amount of students in the poll. So we're going to take 10% of 880, and mathematically that would be 0.10 times 880. This one comes out a lot nicer than the last example. This comes out to 88 students. And one more example here. Here's a circle graph below that shows how many $2 candy bars were sold during a fundraiser. So this one here, you'll notice, it does not give the percentages. It gives the actual total that each student sold. So sometimes circle graphs will do that, where you can kind of visually guess the percentages, but ultimately we'll talk about here in a second how we find the percentage. So part A, how many candy bars were sold in total? So what's nice about this graph is that you're given each student's amount of sales, you can just add them up. So we have 15, 24, 10, and 9. All together, that's 58 candy bars. Part B is asking what percentage of candy bars did Jen sell? Well, if I want to find her percentage, all I have to do is take the amount she sold 9 of them, divide it by the overall amount of candy bars sold, 58. So you would do 9 divided by 58, which would come out to 0.155. And again, your rounding this can be a little bit different. If you're doing this in IXL, more than likely they're going to give you cleaner numbers to work with. But again, round however it's telling you to. If I want to turn a decimal to a percent, remember the trick. You can either multiply it by 100 or move the decimal 2 places forward. It's roughly 15.5%. And again, if you wrote that, if you were doing it on your own and you rounded that to 0.16 and made it 16%, that would be fine as well. Part C, to win a prize, a student must sell at least $30 in candy bars. Who's eligible to win the prize? Well, if I look at my circle graph, it just simply tells me how many candy bars they sold. But if you go back to the original prop, each candy bar is $2. So if I want to figure out who sold at least $30 in candy bars, all I got to do, take each student's amount of candy bars, multiply it times $2. So if we start with Jen sold 9 candy bars times $2. She only sold $18 worth. No prize for her. We've got Mario, who sold 15 at $2 a piece. He sold 30. So the qualifier is at least 30. 30 is at least 30, so that means it has to, again, be the same or higher. So Mario would be eligible to win a prize. You've got Sally, who, again, sold 10 at $2 a piece. So $20 worth of candy bars, no prize for Sally. And then Janelle, who sold the most, 24 times $2. She sold $48 worth. So she would be eligible to win the prize. So Mario and Janelle would be your correct answers for that. So again, just using circle graphs, a lot of it again is just comparing percentages, just doing some basic math to do some basic interpretation with them. So the IXL that goes with it, again, remaining in level I, BB12 is your topic. Again, get your score up to an 80 for full credit. And as I keep saying in these last couple of videos here, make sure you're keeping up with these. Again, we have very few school days left, and I'm sure all of you have other work and other things and more pressing classes that you need to get done. Take care of this early, and that way you won't have to worry about it, and I won't have to pester you. So with that being said, if you have any questions on anything, as always, send me a message on Schoology, shoot me an email, stop by my office hours on Zoom, and I will be happy to help you out. Otherwise, as always, stay safe, stay healthy, and thank you for watching.